Bismillahirrahmanirrahim. I am Absar Saleh and my co-presenter is Hassan Faraz. We are the student of batch 8 of Chemical Engineering at ComSat's Institute of Information Technology Lahore. I am going to present here biomass to energy and its future. In the contents of the presentation are the introduction, conversion to energy methods, energy production, application to the common life, and the future benefits. We have chosen this topic for the presentation because Pakistan and most of the developing countries are in energy crisis. Pakistan spends almost 7 billion US dollar on import of fossil fuels annually to fulfill its energy needs. The renewable and sustainable energy sources are the best substitute to the conventional fuels and energy sources. Pakistan takes the opportunity to have almost of its population rural, having a large amount of animals that gives 652 million kg of manure daily from cattle and buffalo only. This can be used to generate 16.3 million cubic meter gas per day and 21 million tons of biofertilizer per year. So by installing the biogas units or biomass gasification units, we can overcome the energy crisis which we are facing too. They are low cost and can be run with very small budget. Biogas energy corridor can work as good as substitute for nearly 70% of country's population residing in rural areas. Installation of plants to store the biogas can be an additional opportunity. The need of a national policy is imperative to bring the technology at the farmer's doorstep. We are going to discuss two methods of converting biomass to energy that are very well known. The first one is biomass gasification and the second one is biomass digestion. In the biomass gasification process, the conversion of solid fuels into combustible gas mixture, which is often called as producer gas, takes place. The producer gas is a mixture of carbon monoxide, hydrogen and methane. The whole process involves combustion of biomass which takes place in a gasifier. In the gasifier, four processes are done: drying, pyrolysis, combustion and reduction. In drying, the evaporation of biomass is done for efficient burning of biomass. In pyrolysis, the long chain hydrocarbons are broken into light chain hydrocarbons. In the combustion, the burning of biomass takes place, and in the reduction, finally the biogas is produced. This is a process flow diagram of biomass gasification process to understand how biomass is converted into energy. In the figure on the very left, a gasifier is shown. From the gasifier, biomass is converted into gas, and that gas is used as a fuel in a boiler. From boiler, steam is produced that dries the turbine and then the generator, and finally the electricity is produced and used by the consumer. Here is shown a biomass gasifier. You can easily see or understand the four different processes that took place in a biomass gasifier: drying, pyrolysis, combustion, reduction, and finally the ash removal. Here is shown the composition of the producer gas that is produced at the end of the biomass gasification unit. Here is shown the comparison of the ratios of gases that are produced in the producer gas using different biomass materials: carbon monoxide, hydrogen, methane, nitrogen, carbon monoxide, gas generated and gas calorific value. This is the best part of the presentation, that where we can utilize the energy produced from the biomass. It has two major areas of utilization: power generation and thermal application. In power generation part, we can use the electricity produced from the biomass in irrigation pumping, village electrification, captive power, industries, grid-fed power from energy, plantations and wastelands, simultaneous charcoal and power production. And in thermal applications, hot air generators, dryers, boilers, thermic fluid heaters, ovens and furnaces and kilns. The major environmental aspects of biomass gasification process are water, air, noise and solid waste. Water is used in recirculation mode with zero discharge, occasionally used in pH adjustment or in simple treatment if required. Air is only used in the gasification process for the combustion of the biomass. In the category of solid waste, Charcoal and biological ash are the waste of the biomass gasification unit. Charcoal can be further sold as a fuel, and the biological ash can be returned to the soil as it is not very harmful. And in the category of noise, the gas has 100% lesser noise than the liquid fuels. The alternate method for the production of energy from biomass is the production of biogas from the biomass digestion using a biogas plant. In this process, mainly methane and CO2 are produced. Methane is odorless, colorless, having good calorific value and a greenhouse gas. The raw materials of this process are animal manures, excreta, kitchen waste, industrial and chemical processes, seawater bed, etc. Animal manure and excreta contributes around 16% of the total global methane emission. In the figure, there is shown a biogas plant. The biogas plants mainly consist of four parts: mixing tank or inlet tank, gas holder, digester tank, and the overflow tank. In the mixing tank, the slurry of water and the biomass or bio-waste is prepared and then dosed into the digester tank. In the digester tank, the digestion takes place and the gas is collected into the gas holder, and then the biomass is discharged to the overflow tank and the gas is used by the consumer. The idea of biomass to energy has a lot of benefits. It contributes substantially in reducing global warming, cost-effective replacement for fossil fuels. This smoke-free gas emits less carbon dioxide as compared to other fuels, a very efficient and environment-friendly solution for disposing of various organic matter. With the rapid increase in the population and industry, energy needs are on rise. Almost 7 million cubic meter wood is used for commercial and domestic purpose annually in Pakistan. Biogas energy generation systems are in demand and their number is increasing steadily. They are cheaper and can be run with very low operating cost. The bioenergy corridor can work as a good substitute for nearly 70% of the country's population residing in rural areas. At present, many agencies like PDDC, PCRET, and RSPN are working to disseminate the renewable energy technology. But the need of a national policy is imperative to bring the technology at the farmer's doorstep and boost its success rate. And thanks for watching this video.